In this lesson, we're going to talk about quadratic inverses. A quadratic inverse occurs when the original function is a quadratic. And as you'll recall from grade 10 math, a quadratic is going to have an exponent of 2. It's going to take the form of a parabola. Well, imagine that f of x was equal to 2x squared minus 12x plus 17, and we wanted to determine an expression for f inverse of x, and then graph y equals f of x and y equals f inverse of x on the same Cartesian plane. Well, we know that inverses involve switching x with y, so a good idea might be to get this original expression in vertex form. The advantage to getting it in vertex form is that we only have one y on the left and one y on one x on the right, and so switching is kind of easy. So what we do is we get the expression into vertex form. Now, however you do that is fine. In this example, we're completing the square, but you might choose to use partial factoring or shortcut method or some other method of doing that. But you factor the 2 out of the first two terms, and then you take this coefficient inside the bracket of x, you divide it by 2, and then you square that and you get 9. You then add 9 and subtract 9 inside the bracket. Now you're allowed to do that. Then what you do is kind of interesting. You distribute the 2, but only to the negative 9, thereby kicking it outside the bracket and making it negative 18. And then at the end, you simplify. The bracket reads x squared minus 6x plus 9. That is x minus 3 quantity squared. And then you simplify negative 18 plus 17 is negative 1. Now what we're going to do, because it's an inverse question, we're going to switch x and y. So x becomes 2 times y minus 3 quantity squared minus 1. Remember, we want to solve for y. So we add 1 to both sides, and then we divide both sides by 2. Now at this point, we need to square root both sides, but remember, because we're square rooting and solving for something that's being squared, we need to put a plus or minus in front of the square root. So we do that here, and then finally we add 3 to both sides, and we have an expression for y. One thing I'd like to mention is make sure your square root extends down far enough that it's actually also incorporating the denominator. In this case, the denominator's 2. We don't want to make our square root so casually that it's hard to tell if you meant for that 2 to be included or not. Make it clear that you mean for it to be included. And also, don't draw this, the roof, don't draw it so far that you can't tell if the 3 is part of it or not. It's up to you to be clear about what's underneath the radical and what's not. So we get f inverse of x is equal to plus or minus the radical x plus 1 over 2 plus 3. Okay, now we want to graph the original function and the inverse on the same curve, so we're going to graph the original function using grade 10 methods. The original function has a vertex at 3, negative 1, and it opens up. And sometimes people say, well, I know there's a vertex here and I know it opens up. I don't know how wide to make it. A little rule of thumb, which always works, is this. Look at whatever the lead coefficient is when it's a parabola. Look at the coefficient of the lead term. Now, move 1 square to the left and 1 square to the right. Whatever that lead coefficient is, in this case it's 2, that tells you how many squares up or down to go when you move 1 step to the left and 1 step to the right. So in this case, since the lead coefficient is 2, we know that we're going to go 2 squares up and 2 squares up. So that gives us a couple of more points on our parabola, and that makes us able to draw a nice parabola knowing how wide we should make it. Okay, so that's what the original function looks like. Now, since the original function has a vertex at 3, negative 1, the inverse will have a vertex at negative 1, 3. And since the original function has points at 2, 1, and 4, 1, the inverse will have points at 1, 2, and 4, 2. And so we can see that we're going to have a sideways parabola going through the points which we just sketched. Okay, so here we go. Since the original function's a parabola, the inverse is also a parabola. Since the original has a vertex at 3, negative 1 and passes through 2, 1, and 4, 1, therefore the inverse has a vertex at negative 1, 3 and passes through 1, 2, and 4, and 1, 4. 1, 2, and 1, 4. So this is what the inverse looks like. Now, the red curve is the curve y equals plus or minus square root of x plus 1 over 2 plus 3. That's what that two-armed red curve parabola is. Well, what's kind of interesting is if you focus only on the top arm, the one that I'm highlighting right here, if you focus only on that, that is y equals positive square root of x plus 1 over 2 plus 3. And if you focus only on the bottom arm, that's y equals negative square root of x plus 1 over 2 plus 3. And you put this positive and this negative together, and you get plus or minus. So that is a fact that will be true in all of these subsequent cases. So the top half of the sideways parabola has the equation y equals positive square root of x plus 1 over 2 plus 3, and the bottom half of the sideways parabola has the equation y equals negative square root of x plus 1 over 2 plus 3. Together they make y equals plus or minus square root of x plus 1 over 2 plus 3. There's the positive, there's the negative. It will always be this way when we start with a quadratic function, i.e. a two-armed parabola opening up or down. So if we have a two-armed parabola and it's opening up or it's opening down, this will happen. The quadratic will be in vertex form, and then we'll determine the formula for f inverse of x like we did in this presentation. There will be a radical with a plus or minus in front. The top arm of the parabola will be represented by the expression for f inverse of x, but with only the positive in front. And the bottom arm of the parabola will be represented by the expression for f inverse of x with only the negative in front. All right, here's another question. Given f of x equals this expression here, determine an expression for f inverse of x and graph y equals f of x and f inverse of x on the same Cartesian plane. So we don't have to convert to vertex form. That's kind of nice. We let y equal the quadratic expression. We switch x with y, and then we go about solving for y. Some students do this all in one step, and that's fine if it's accurate. Adding 2 to both sides, then we divide both sides by negative 3. Then we take the square root of both sides, and we've now solved for y plus 4. Remember to put a plus or minus in front of the square root sign. We subtract 4 from both sides, and we now have an expression for f inverse of x. Again, you can do all that in one step if you can, but if you're not sure how to do it step by step. Now, we are able to draw the original function and the inverse. So let's look at this. The original function from grade 10 math, we know has a vertex at negative 4, negative 2. Because there's a negative 3 in front, that's the lead, the coefficient of the lead term. That means if we go one step to the left or one step to the right, we're going to go down 3 units. Well, what we've just done is we've given ourselves 3 points on the original function on the curve of y equals f of x. Those 3 points are the vertex of negative 4, negative 2, as well as negative 3, negative 5, and negative 5, negative 5. Well, if we have these 3 points on the original, then 3 points on the inverse are pretty easy. We just switch the x with y in each one of these cases. Easy peasy. So then we can draw a parabola with a vertex at negative 2, negative 4, which also goes through these 2 points right here. and that's what the red curve is. Okay? The blue curve is y equals f of x, and the red curve is y equals f inverse of x. Okay? So, like we say here, the blue curve is the original expression. The red curve is plus or minus y equals plus or minus the square root of x plus 2 over negative 3, quantity minus 4. Now, we can not just talk about one arm of a sideways parabola, we can also talk about one arm of a parabola that opens either up or down. If we want to talk about only the right arm of the original function, only that arm of it, well, what we do then is we say y equals negative 3 x plus 4 quantity squared minus 2. But then we also say x must be greater than or equal to negative 4. By putting this little piece at the end, you've told me only look at the right arm of that parabola opening downwards. Okay? But on the other hand, if you only want me to look at the left arm, of the left arm of that parabola opening downwards, then you would say y is negative 3 bracket x plus 4 quantity squared minus 2, and then you would say x must be less than or equal to negative 4. Well, what's interesting is if you say x is less than or equal to 4 and restrict the function so that it's only has one arm, then when you determine its inverse, you must only put a negative in front of the square root. But going backwards one slide, if we put going backwards one slide, couple slides, if we put x greater than or equal to negative 4, and in that way say we're only using the right arm of the downward parabola, then we only put a positive sign in front of the square root. Okay? Now, similarly, it works the other way. So if instead of saying that the original function is this, and that the inverse will have a positive in front of the square root, it's possible to say that this is the original function. In other words, that the original function is y equals square root of x plus 2 quantity over negative 3 minus 4. And then to determine the inverse of that, which would be negative 3 bracket x plus 4 quantity squared minus 2, and then with the added statement that x must be greater than or equal to negative 4. Or if you start with the radical version and you have a negative in front of the square root, then that means when you determine the inverse, you're going to have to qualify it by saying x must be less than or equal to negative 4. So, to summarize, a two-arm parabola opening up and a two-arm parabola with a plus or minus in front of the radical opening to the right are each other's inverses. A two-arm parabola opening down and a two-arm parabola with plus or minus in the radical opening to the left are each other's inverses. Now, if I have the right arm of a parabola opening up, I know it's the right arm because I say x is greater than or equal to 3, then I'm going to have the upper arm of a parabola opening to the right. I'll have a positive sign in front of the square root. Now, of course, when you put a positive sign in front of something to indicate that it's positive, you can also choose to not put anything there at all, and we'll know it's positive. Okay? And it also works the other way. So if you begin with this function here and you want to know its inverse will be that one up there. Okay? The right arm of a parabola opening down and the upper arm of a parabola opening to the upper arm of a parabola opening to the left will be each other's inverses. I know that I'm keeping the right arm of the original function because it says x greater than or equal to negative 4, and I know I'm keeping the upper arm of the sideways opening parabola because I've got a positive in front. The left arm of a parabola opening up and the lower arm of a parabola opening to the right will be each other's inverses. I know I have the left arm because it says x less than or equal to 3, and I know that I have the lower arm of the sideways parabola because there's a negative in front. And finally, the left arm of a parabola opening down, or the lower arm of a parabola opening to the left, they'll be each other's inverses. I know it's the left arm of the parabola, and I know it's the lower arm of the sideways parabola. Okay? So let's do a few examples here. In this one, let's imagine that f of x is a one-armed parabola. I know it's a one-armed parabola because of this right there. Because it's x greater than or equal to -1, I know it's the right arm. Now, you might say, how do you know what x value to let it be less than or equal to? In other words, how do they come up with the -1? It's always the x value of the vertex. Okay? So, suppose I say to you, f of x is the right arm of that parabola shown. We want to determine f inverse of x, and then we want to graph and state the domain and range. So, what we can do is we can ignore the part that says x greater than or equal to 1. We can ignore that and simply say let y equal this part. Now, you might be tempted to say, sir, you can't just ignore something like that. We actually technically can, because in the question, there's no y. Y isn't anywhere in that question. We're introducing it. And because we're introducing it, we're allowed to let it be whatever we want. So in this case, we want it to be the original function without the qualifier of x greater than or equal to -1. Then what we're going to do, we're going to switch x and y and follow the usual steps to isolate for y. And we get that y must be plus or minus the square root of x plus 4 over 2 minus 1. So you might think, okay, that tells me what f inverse of x is. But not so fast. Because the original function has a qualifier. Because of that qualifier, it's a one-armed parabola, and it's specifically the parabola on the right. So that means I don't want to have both of these arms. I only want to have one of them. I'm only going to want to have the one on top. I only want the positive one. So this ends up being the equation of the inverse. Okay? Now, when I go to graph that, it's easy enough for me to graph this curve. I can say that curve has a vertex at -1, -4. And if I go one step to the right and 2 squares up, I get another point. So I've got the point -1, -4, and the point 0, -2. Now, how did I know to go one step to the right and 2 squares up? I knew that because of this number 2 right there. Now, sometimes I've seen people do this. They just sort of, you can see them sort of sketch out the second arm just to give themselves an idea of what that parabola would look like. But then they realize really quick, no, I'm not supposed to have that one at all. Now, they've got 2 points on the original function. It's really easy to determine 2 points on the inverse. Just switch x and y of the originals. And now draw one arm of a parabola going through both of those points. Okay? The domain of the blue curve is x greater than or equal to -1, and the range is y greater than or equal to -4. And that tells us what the domain and range of the inverse will be. You may recall from earlier that the domain of the original will be the range of the inverse, and the range of the original will be the domain of the inverse. Okay, now what if we have a one-arm parabola, but instead of keeping the right arm, we're keeping the left arm? Well, similar process. For now, ignore the x less than or equal to 2 and let y equal the expression without the qualifier. We're going to switch x and y, and then we're going to solve for y. And we get to y equaling plus or minus the square root of x over -3 plus 2. And on first glance, you might think, okay, that's f inverse of x. But we're only supposed to keep one arm. So I don't want 2 arms on my inverse. So I'm only going to keep the negative because the qualifier originally was that x is less than or equal to 2. And I can graph these functions. Now again, it's easy to determine a couple of points here. The vertex is 2, 0. And if I go, that's right here, and if I go one step to the left or one step to the right, I end up with a point 3 units down. So using that philosophy tells me that another one of my points will be the point 1, negative 3. So I've got 2, 0, and 1, negative 3. That tells me that the inverse will have a point at 0, 2 and another point at negative 3, 1. Okay. We can state the domain and range of both the original and the inverse and note the similarity as mentioned before. Now, what if instead of being given one arm of a quadratic function that opens up or down, what if we're given one arm of a sideways parabola? Now, we know that a two-arm parabola is not a function because it fails the vertical line test, but one arm of a sideways opening parabola would be. So what we've got here is a function, and I know it's only one arm because there's no plus or minus in front, it's just a positive. So let's determine f inverse of x. We're going to let y equal that expression. We're going to switch x with y. And then we're going to subtract 4 from both sides. Then we're going to square both sides. When you square both sides, you get x minus 4 quantity squared equaling y minus 3 over negative 2. Multiply both sides by negative 2 and add 3 to both sides, and you're going to get negative 2 times x minus 4 quantity squared plus 3 is equal to y. Now, you might think on first glance that f inverse of x is equal to negative 2 times x minus 4 quantity squared plus 3. But it can't be. The reason is this right here is a one-arm parabola because there's only a positive there. But this is a two-arm parabola because there's no qualifier on the end. Interesting. So what we have to do is we have to put a qualifier on the end. We have to say x is greater than or equal to 4. If there's a positive in front here, there's going to be an x greater than or equal to on the end. What x value is it greater than or equal to? Simple, the x value of the vertex. And this is what these curves look like. Now, interestingly enough, perhaps, I find it easier, instead of trying to graph this and then graph its inverse, I actually find it easier to graph the inverse. I find it pretty easy to graph y equals negative 2, x minus 4 quantity squared plus 3, x greater than or equal to 4. This, to me, is a pretty easy thing to graph in comparison to this. So I start by graphing the easier one, the inverse. Then I graph the inverse of the inverse, and interestingly enough, the inverse of the inverse is the original. So I graph the inverse. After I do that, I switch x with y. I switch x and y for a couple of critical points, and that allows me to graph the original. It's up to you. If that's a way you like to do it, that's cool. And we have the domain and range stated on this slide. And one more question here for us. Suppose we have a sideways parabola and we only have one arm of it. We have the lower arm because there's a negative in front. If that happens, then we've got like we say, we got the negative in front there. We have a one-arm parabola. We're going to now determine the inverse of that. So we let y equal this expression, and then we switch x with y. We subtract 2 from both sides, and now we want to square both sides. If I square negative y minus square root of y minus 1 over 4 times negative square root of y minus 1 over 4, these two negatives multiply each other and become a positive. So what I get is positive square root of y minus 1 over 4 times positive square root of y minus 1 over 4. And that is equal to y minus 1 over 4. So the negative sign in front falls away when you square it. And sometimes that throws some people off. So we end up with x minus 2 quantity squared equaling y minus 1 over 4. We can now multiply both sides by 4. And then we can add 1 to both sides. And we have an expression for y. And sometimes students think that's their inverse. But of course, just remember, we began with a one-arm parabola because there was a negative in front of that square root. We're not allowed to finish with a two-arm parabola. Because we began with the one-arm parabola, the lower arm of a sideways opening parabola, in other words, because we had a negative sign in front of the square root, our final answer should have a qualifier of x being less than or equal to something. And what is that? Well, since the x value of the vertex is 2, that's the qualifier that we should put on, x less than or equal to 2. And that is our final answer. Okay, so then we graph both the original curve and the inverse, and we state the domain and range of each. I hope you have enjoyed this lesson.